Hello there, my little mathematicians. Today we are going to review the introduction to integers. So you should have had a foldable that you printed double-sided to flip on the short side. Okay, so now you have these two pieces of paper. You're going to put them together like this, and then you'll see this line right here. Okay, you can do it individually, but why not put them perfectly close together and cut them at the same time. Hold it firmly in your left hand and then cut along that dotted line. Once you have your two pieces of paper cut on that dotted line, you are going to take your two pieces of paper in your hand. You're going to find the one that says absolute value. So if you flip it over, it should be right there. Put that flat down on your desk. Okay, absolute value is down on your desk. The other piece of paper is in your hand, and it should say comparing and ordering. If not, flip it so it does, and slide it down. So again, absolute value is flat. Take the piece of paper that says comparing and ordering and slide it down on top so that it's almost covering it. It looks like this. Okay, once you have it like this, you are going to put these two fingers here and here, like kind of hold it in place, and then you're going to fold the top part down. Okay, so again, those other two fingers are kind of holding it in place, and then you just fold it down. Once you have it, it looks like this nice little neat booklet, and you just put one little staple at the top. Don't put it way far down because you're going to want to be able to write. So just kind of put it a little bit close to the top so it keeps it all close together. And now you have this nice little booklet that we're going to go through. We're going to review section 1.1 of integers and their opposites, 1.2, which was comparing and ordering, and 1.3, which was absolute value. Okay, so once you have that, go ahead and open it up. And I suggest waiting to glue it in until after you write on it. It just makes it easier. Okay, and remember, you can always pause the video if you need it to slow down, or speed up the talking or slow down the talking. Okay, the definition for opposites. Opposites are simply numbers that are the same distance from zero. So numbers that are the same distance from zero. So for instance, what do you think the opposite of -2 is? 2, because -2 is 1, 2 away from 0, and 2 is 1, 2 away from 0. So opposites, the formal definition, in case you had to like match it, was numbers that are the same distance from 0. Okay. We move on to integers. Integers are the set of all whole, of course my pen is dying, whole numbers and their opposites. Meaning whole numbers, it doesn't include any fractions, okay? So if they ask you to use an integer, then it's only whole numbers, like what's shown on this number line. But if they say use a rational number, it includes integers plus the things in between, like -1/2, -3/4, -1.59, or on the positive side, 3.5162. Okay, anything that's a fraction or a decimal, that's a rational number. Integers are just the whole numbers and their opposites. Okay, so let's in fact actually draw a little thing right here to let us know that all these numbers on these number lines are integers. And then it seems silly to even say it, I know you guys know, that from -1 all the way on, these are what's called negative numbers or negative integers. Okay, they are to the left of 0, always. Okay, negative numbers are always going to be to the left of 0. And then you have positive numbers starting with 1, moving in that direction, and those are always to the right of 0. Notice how I didn't include 0 in either of those groups. 0 is neither positive nor negative. Now hopefully this is somewhat of a review. If not, it was a good refresher. Okay, the opposite of each number. What's the opposite of 7? Hopefully you said -7. What's the opposite of -3? Hopefully you said 3. What's the opposite of 0? Trick question, there is no opposite of 0. It's just still 0, okay? There's no such thing as a -0. Graph the opposite of the numbers shown on each number line. So first of all, what's the opposite of 2? -2. So to graph it, all you do is draw a dot at that number. The next one says, what's the opposite of -3? That's +3, so draw a dot at +3. What's the opposite of 5? -5, so draw a dot at -5. Okay, you just reviewed that whole first section of 1.1. Moving on to 1.2, comparing and ordering, I want you to just flip your foldable up. Okay, and it says graph the numbers on the number line, then order them from least to greatest. Okay, so first of all, just draw a dot at each number. -1, -7, 3, -5, 9, 0, and 4. Always double check that you got them all. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 dots. Okay, and then when it says from least to greatest, that's small to big. The further left you are, the smaller they are. So start with the -7, then -5, -1, 0, 3, 4, and 9. And again, always double check. 1, 2, 3, 4, 5, 6, 7 numbers. Good, I didn't accidentally miss any. Okay, now it's helpful, as you could see, like if I just quickly draw them on a number line, then I can very easily list them from least to greatest. However, that's not very practical if you're given numbers like -54. I don't know about you, but I don't want to have to graph that. It seems like a pain. So I would just quickly draw a little brief number line, like 0, 1, 2, 3, -1, -2, -3. So I can kind of use it as a reference and be like, okay, the bigger the negative number, the smaller it actually is. So if it wants it from least to greatest, I want the largest in value or the biggest negative number. That's actually the smallest in value. So look for your biggest negative. Aha, -92. Then what's your next biggest negative number? -54. Your next biggest negative is -17. Then -3. Now you're into the positives and you know how to do that. You just go from small to big. So 8 is my next one, then 21, then 51, and then 89. And always, you guessed it, count. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 in my list. I got them all. They are now listed from least to greatest. Okay, sometimes they'll ask you to list them. Other times they will ask you to compare them using what's called an inequality sign. If they ask you to compare them using an inequality sign, remember that this one means is less than. And I can remember that because it kind of almost looks like an L for less than, right? It's just tilted slightly. And when you read something from left to right, the little tiny dot end is pointing towards the left, right? Versus this one, the is greater than sign, the great big open end is facing towards the left, okay? Because you read from left to right. So is a negative number bigger or smaller? A negative number is smaller, less than a positive. Okay, a positive number is greater than a negative. 0 is greater than a negative. See if you can pause and try to figure it out before we go over it together. A negative number is always less than a positive. Here's where it's tricky when you're comparing two negatives. I would rather owe $2 than owe $9. So this is actually greater, okay? Or this is further to the right. Remember that little number line we reference, the smaller the negative, the larger in value it actually is. So this is greater than that one, okay? Which means this one is the same thing. -6 is greater than -15 because I'd rather owe $6 than owe $15. Okay, moving right along, we just finished reviewing section 1.2. Our final section, 1.3, was absolute value. Okay, the absolute value is the distance a number is from 0 on the number line. Now remember, when you're talking about a distance is always positive. Okay, so since it's always positive, whether I started with the absolute value of -3, well, -3, how far is that from 0? 1, 2, 3 away. It's 3. Or even if it was the absolute value of +3, well, find +3, how far is it from 0? 1, 2, 3 as well. So whether it started as a negative or a positive, the absolute value of 3 was still 3, because absolute value is always positive. I'll save some tricky ones for the end after we get a little bit more practice. Okay, since absolute value is a distance, it is, let's kind of star this guy. Okay, and remember it's a distance, so it's therefore always, we already said it, positive. Really want that to sink in. Okay, so meaning what's the absolute value of -17? Hopefully you can race through this. And then I'm going to give you some challenging ones. The absolute value of 5 is 5. Absolute value of 0 is still 0. Absolute value of -2 is still 2. And the absolute value of -9 is 9. And the absolute value of 83 is 83. Okay, those were pretty easy. The only way it could be tricky, let's say you had this and this, okay? You had these two problems. First off, you want to take the absolute value of 10. What's the absolute value of 10? 10. And then it's saying the opposite of that, so you bring down that negative, okay? Because the absolute value of 10 is -10. Because that negative sign out in front is saying the opposite of this. So you work your way inside out. Take the absolute value first, then bring down that negative sign. Right here, what's the absolute value of -10? Just 10. And then what's the opposite of that? A -10. Okay, so I took the absolute value of this and then I brought down that negative essentially. Okay, that's the only way that this could get a little bit tricky, is if they have that negative outside of it, because it's saying the opposite of this. All right, this is as complicated as it can get. Other than that, this section is pretty easy. Congratulations on mastering 3 new concepts.